Okay, continuing on with section 11.5, areas of similar figures, starting on page 821. We're now on number 15, picking up where we left off in the last video. And the place where we left off is that we had just found the scale factor of the smaller pan to the larger pan, which is 6.45 to 7.25. Now we're going to use this scale factor to find a missing length. We can use this scale factor to find a length of the smaller one or to find a length of the larger one, depending on the known value. Since we have a side length of the larger pan, which is 4.5 inches, we can use that to find a corresponding length of the smaller pan. We just need to make sure to put it in the right order here. So since my scale factor is set up as smaller to larger, then I need to set this up in the same way. So since I know the larger, that would go in the denominator here. And I want to find the corresponding length of the smaller, so in the numerator here, and then we cross multiply. So we take 7.25 times x, which is equal to 6.45 times 4.5. Now from here, we would just need to divide by 7.25. And x is 4 inches. So the corresponding length on the smaller pan is 4 inches, if on the larger pan it is 4.5 inches. Alright, and part B, it says the recipe that Caitlin is using calls for a circular cake pan with an 8-inch diameter. Which pan should she choose? Explain your reasoning. To do this problem, first we would need to find the area of the base of a circular cake pan with an 8-inch diameter. So if the diameter is 8 inches, the radius is 4, and the area is pi r squared, so pi times 4 squared, and we get approximately 50.3. Now that we have this answer, we just want to choose the answer in the first part of the pan that the area is closest to. So 50.3 square inches is closer to 52.61 square inches than it is 41.6. So she would choose the larger pan. Number 19, find the area of each figure. Use the segment length given to find the area of the similar polygon. So the area of triangle JKL is equal to half the base times the height, where our base is 5 and our height is 6. So we get 15 square units here. We want to find the area of a similar polygon. So first we have to find our scale factor. which would be a side length of this to a side length of that. So we have 3 is to JL, which is 5. Our ratio of areas will be this ratio squared. And now we can use this ratio of areas to find the missing area. So notice as I have here the order that I have this in, so I want to make sure to put the area of JKL in the denominator and then cross multiply. And divide by 25. And there's our area of the other triangle. Okay, so to find the area of this next figure, I'm going to split it up into 2 triangles. Where the triangle ABC has a base of 6 and a height right here of 2. And triangle ACD would have the same base, but its height is 4. So if we add our 2 areas together, we get a total area of 18 square units. The next thing that we need to do is find our scale factor. So we have a length of BC prime, we need to find the corresponding length BC. So to find the length of BC, we have to use the distance formula. So here are my coordinates for B and C, and I'm going to substitute those into my distance formula. So I'm going to take x2 minus x1 and take that quantity squared plus y2 minus y1. And then take that quantity squared. And then from there I'm going to simplify. So -1 minus -3 or plus 3 would be 2 squared, and 5 minus 7 is -2 squared. So in both cases I would get 4, and 4 plus 4 is 8. So my distance is the square root of 8, which is approximately 2.83. So my scale factor of BC to B prime C prime would be 2.83 to 5. But we want to find area, so we want to square this. So instead of actually squaring this value, remember that 2.83 is equal to the square root of 8. So when we square that, we just get 8. And 5 squared is 25. Now we have our ratio of areas. So the area of ABCD is 18, and the area of ABCD prime we don't know. So once again we would cross multiply, and divide. And there we have the area of ABCD prime.